Welcome back to the channel. Today we are going to talk about important topic, QuadTrees. Have you ever wondered how map-based applications like Google Maps or location-based services retrieve nearby businesses or points of interest so quickly? One of the key data structures that powers this is the QuadTree. It is in today's video we were going to explore what a quad tree is, how it works, and why it's powerful tool for partitioning and searching two-dimensional spatial data efficiency. So let's try to understand. Let's say that we have a map, and this map is about 200 meters square. 200 meter square. Okay, let me scroll for you guys to see it. A quadtree is a hierarchical data structure used to portion two-dimensional space by recursively subdividing it into four regions or quadrants. This process continues until the contents of each region meets a specific criteria, such as the number of objects within that region. In simpler terms, imagine starting with a word map. The root node represents the entire map. We recursively divide this space into four smaller regions or quadrants. So as long as the number of businesses or points of interest in each region exceeds a certain threshold. So there is, for example, 100 business. So how does it works? We have right now 100, so we will divide it into four. So we have four different. Okay, I guess it would be better to make like yep, something like that, and make it white, and something like that, and make it as well white. So we divide this map into four, and each one, for example, will have like this one has a like it's too thick. This one has like a 40, and this one has example like 30, and this one has like 70 meter, and I guess 60 is left. So we cover the 200, and we continue doing that, and the tree will look like something like this. We will have the 200, for example. It will be divided into four different children. It will be like 40 meter, 30, and 60 and 70, 70 and 60, and recursively it will split itself. So the 30, for example, will split itself in four childs, and we have like, let's say like 12, 4, 5, and what will be list? 9. As well, we can do the same in the 4 here. So it will be like I don't know, like 1, 1, 1, 1, like no other solution, because before I guess I should take 9 instead. So this is how the quad tree looks like. So at the startup time, a location-based service server, the quad tree is built in memory. The root node covers the entire map, and it's recursively subdivided into four quadrants until no nodes has more than the set of threshold of businesses. Say that we have like let's say that we have like a big map, and this map is from 200, like let's say it's space 200 meter, and we will keep dividing it into smaller pieces. Okay, we keep dividing it into four pieces, something like that, to make sure that each node has only, like, for example, each node has I guess, like, let's say that 100 business and nothing more than that. Think of like a Yelp or something that will search for places like businesses in Yelp, for example, or maybe Google Maps. So this is how it works. So once the quad tree is built, it can efficiently answer questions like, where are the nearest businesses to my current location? So how it works, so first we start from the root node. We start here. Let's give this different color. So first we start from the root node. And we traverse down the quad tree to locate the leaf node containing the search origin. So your current location, for example. If the leaf node contains 100 business or fewer, we return those businesses. If the leaf node does not have enough businesses, we expand the search to neighbor nodes until enough businesses are returned in to satisfy the query. So let's say that we are searching for like a nearby restaurant or something like that. We go to the 200 and we go to the leaf node where we are located. In this leaf node, if in this leaf node we have, like, for example, 100 business, let's assume that our criteria is 100. We will return them. If let's assume that we have only 20 business, so we try to go to like some sort of neighbor leaf nodes and add them. So we expand to make sure that we get all the time the criteria that we want, and the 100 business that we want. So this traversal process makes QuadTree highly efficient as it avoids searching the entire dataset and instead focuses only on relevant regions. But what happens when new businesses are added or the location-based service server needs to update to be updated, for example? So let's talk about the update process. Rebuilding a quad tree with a massive data sets like 200 million businesses, for example, can take several minutes. During this time, the server cannot serve any requests. To avoid the downtime and to ensure smooth user experience, there are some best practices. One of them is to do like a rollout updates incrementally to small subset of servers at a time. Second, we can maybe like this also prevents taking a large portion of server cluster offline, reducing the risk of services disruption or brown note no out. So by rebuilding the quad tree incrementally, location-based services can scale effectively while maintaining high availability. And I created a video about that talks about quad trees because in the next video we're trying to make a system design for um, um, a proximity service, something like Yelp or something like that. But we need to understand why the quad tree is so important. So there are several reasons why the quad tree is pretty important, and we try to go up with all of them one by one. The first thing we have will be the efficient partitioning. It's really efficient because it divides large two-dimensional space into manageable regions for faster queries. Also, it optimizes search, like it narrows down search areas, reducing the need to scan the entire dataset. It's like in memory performance is great. Like by building the quad tree in memory, businesses can be located quickly and efficiently. And lastly, scalability. So it handles massive datasets like 200 million businesses without overwhelming the system. So a real world example for that, like Google Maps, that ride hailing apps and delivery services use similar data structures like QuadTree to efficiently fetch nearby locations. Whether it's a restaurant, delivery points, or users, or whatever it will be. The combination of recursive space partitioning and neighbor search ensures that location-based queries are resolved quickly, even at scale. So, um, so that's how QuadTree works, from efficiently partitioning maps to delivering a real-time search results for millions of users. The QuadTree is it's a great data structure in in specifically in location-based system. It's an important topic. So yeah, that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you will never miss any video, and see you guys in future problems.